So this problem is asking about the extreme value theorem. And I'm going to check chat. Can you tell me what conditions need to be met for extreme value theorem to work? Right. Continuous over the closed interval. So you want to look at each of these functions and realize that what they're actually asking is which of the following functions are continuous over the closed interval 0 to 4. Where does tangent have a discontinuity? So I'm checking chat. Where does tangent have a discontinuity? Where does it have that vertical asymptote? Pi over 2. Pi over 2 and a few other places, but pi over 2 is inside that interval. A is out. I'm going to come back to B. For C, the denominator factors, and I'm assuming you already found that it factors 2x minus 5x minus 4. That means that this function is discontinuous at what 2x values? Now, 5 is not in the interval, but 4 is an edge of the interval, and it has to be continuous through to the endpoint, and it's not. So C is out. And then for letter D, the denominator is 0 when e to the x is equal to 1. For what x value is e to the x equal to 0? 0. I mean, yeah, I said the answer instead of the question. Anyway, now 0 is an endpoint of that interval, so D fails. But what about B? What is the domain of inverse tangent? Correct. It is negative infinity to positive infinity. Keep in mind that when you look at the graph of forward tangent, what is its range? What is the range of inverse tangent? Or I mean regular tangent. The range is all real numbers. That means the domain of inverse tangent is all real numbers. And do you remember what inverse tangent looks like? Goes through the origin and goes, la la la, I'm asymptoting. La la la, so am I. And those are my horribly drawn asymptotes at pi over 2 and negative pi over 2. So, da da da. And I want to repeat, today has a quiz on extreme value theorem, absolute minimum, maximum, critical numbers. And I need to give you at least 10 minutes. If you made it into an equation, there would be zeros in the denominator. Oh, I think you're mistaking the inverse symbol for the reciprocal symbol. And thinking of that -1 as a 1 over. Yeah, arctangent doesn't have a denominator. This makes you think denominator, but it actually means the inverse tangent. And the graph of inverse tangent is continuous for all real numbers. And you can also check by looking at the graph. If you graph arctangent and look at it, you'll see that too. And let's see, next is another question, but I wasn't supposed, no. I wasn't going to do that question. Sorry. I need to go there. Yeah, that's where I meant to go. Okay. Oh, yeah. Oh, that's what you're thinking. Okay. Now, yesterday we learned the first derivative test. Do you remember what the first derivative test was? First derivative test, first of all, said if x has a critical number at c. So f has a critical number at x equals c. Then if f prime changed from positive to negative, that means that f goes la 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 la, or la 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 la, because critical number could mean slope 0, but it could also mean slope undefined. And forgive my drawings. I'm trying to draw on a screen, not on flat paper, and it doesn't work quite as nicely. And then you have a relative minimum if it's negative to positive, and it's neither if it does not change sign. Second derivative test is still trying to determine, do you have a relative maximum or a relative minimum? So the second derivative test starts off with, first of all, it's saying that f double prime is continuous near C. Now, this first bit says if you know at C your derivative is 0. So we're not talking about an undefined slope, critical number. We're talking about C is a critical number and you know the slope is 0. If you also know that the second derivative is positive, what does it mean if you put together first derivative is 0 and your second derivative is positive and you're in the middle of a continuous second derivative? And what I recommend you do is draw that picture. Concave up. So draw that concave up and look at it. Your conditions are the first derivative of C is equal to 0, and you have a positive second derivative. Not absolute, but relative. You got it. So you have a relative minimum at x equals C if you are having a 0 slope in the middle of a concave up graph. That's what it's saying. And then the other one says second derivative negative. So if you are concave down and you are having a 0 slope in the middle of a concave down graph, you have a relative maximum. And now I will erase. I took that out so that you couldn't just see the answer and you had to think about it. Okay, now I've got another question for you, except it's really, I suppose I could have taken the time to make it visible, but I'm going to just share with you what this is and then go over to the table. Okay, now they're telling you that f is a twice differentiable function. That means that you can trust that the table is giving you information of a graph who is itself continuous, it is differentiable, its derivative is continuous, its second derivative is continuous. You've got continuity all across the board. Now, they're asking you about x equals 2 and x equals 8. And they're asking about relative minimum, relative maximum. So here we go. They're asking if f has a relative minimum or maximum. And it was specifically looking at x equals 2 and x equals 8. So I want you to look at this and decide the conclusions about what's going on with f. At x equals 2, what is, and don't answer out loud yet. if you know you have full continuity going on, second derivative continuity and everything, this says when x is 2, you have a 0 slope and a negative second derivative. What does that mean? Concave down, 0 slope, relative maximum. At 8, what's happening with 8? You have a concave up with a 0 slope, relative minimum. Then if we go back over to what the statements were, which of the following statements must be true? What would be the correct answer? Look at it carefully. Look at it carefully. They're cruel sometimes. Yeah. Yeah. This says maximum, not minimum. We found that x equals 2 has a relative maximum. X equals 8 had a relative minimum, not a maximum. And number 1 is trying to say that 2 does not have a relative minimum or maximum. And, well, that contradicts the second one that we already found. So 2 only is the correct answer, which would have been letter B. All right, I have another one for you. And this is combining a little bit of what's on the quiz today and a little bit of what we're learning today. So then I'm going to come back to this picture, but we're going to look at the reading of the problem. This says let f be a twice differentiable function. So continuity all over the place. It wants to know which of the following statements are individually sufficient to conclude that x equals 4 is the location of the absolute maximum of f on the interval 0 to 10. Which of the pieces of information is by itself, standalone, enough information to say there is an absolute maximum at x equals 4? I'm going to give you a short bit of time. I'm going to repeat that it wants to know which individual statement is on its own sufficient to say that on the interval 0 to 10, on the closed interval 0 to 10, that the absolute maximum occurs at x equals 4. And I'm going to have to move forward. I'd like to give you more time, but yeah. So is it enough to just say the derivative at 4 is 0? Woo, absolute maximum. Oh my goodness, no. That is so out. It's just not even funny. Now, number 2, if you know that 4 is the only critical point of f on that interval, and you know the second derivative is negative, is that enough? Now, if x equals 4 is a critical point of f, what are the options? So basically, sometimes people say critical point, sometimes people say critical number. Honestly, they probably should have said critical number, because when you say point, you're referring to an entire xy coordinate. But anyway, so if x equals 4 is a critical number, what are the two possible things that could be happening at 4? A critical number means either the derivative at 4 is equal to 0, or the derivative at 4 is undefined. We were told that this was a twice differentiable function, so which of the following two can't be true? It's defined. So by saying that that 4 is a critical number on f, you know that it has 0 for its first derivative. Now, if it's the only critical point on f, that means that nowhere else between 0 and 10 do you have a 0 slope. It's defined everywhere. That means that everywhere that isn't x equals 4, you either have a positive slope or a negative slope. And then you find out that the second derivative at 4 is negative. Do you agree that it's a relative maximum for sure? We just learned that second derivative test says it is for sure a relative maximum. Is there enough information to say it's an absolute maximum if it is the only critical number on that entire interval? And let me say this. If I were to make a chart for f prime, 0 to 10, I know that my only critical number is 4. I found that the derivative at 4 is equal to 0. And then other than that, as I go from 0 to 4 and 4 to 10, 0 to 4 is either all positive slope or all negative slope. 4 to 10 is either all positive slope or all negative slope. And if I am looking at this concave down nature, do you see that this forces, because I have concave down, the only way for me to be concave down while I'm in the middle of a continuous first and second derivative, that I have to go from a slope that is negative to a slope, from a slope that is positive to a slope that is negative for that concave down to happen. So yes, that actually is sufficient. And then the third one. 4 is the only critical number on that entire interval. You have endpoints at 0 and 10. I'm going to erase what was drawn previously while you're thinking. You know, actually, I'm going to take the y-axis out of the mix. There we go. Okay. This is saying that f of 4 is higher than f of 0, which is higher than f of 10. I know I've got continuity going on. I have no critical point other than 4. And because I've got full differentiability, I've got a 0 slope going on at 4. So if I've got a horizontal tangent line here, and I have no other critical number, must I have an absolute maximum at 4? Yes. These are really tough problems for multiple choice. Multiple choice problems will get easier the more you're exposed to. Just know that and take comfort in that. So with this one, the correct answer was 2 and 3 only. Okay, now, I can't say they will be, they could be on the AP test. There is no guarantee of what's going to show up on the AP test, but there are things that I can say it's shown up every year for the past few decades. So yeah, it's probably on there. But there aren't a lot of things that I can say that to, actually. Okay, now listen up. I first of all know that I did change your homework assignment from what was on the calendar that I posted last Sunday, I think. So I didn't change a lot, I just changed a little bit. And I debated on what to throw in there as I was really looking at it. I decided not to put 31 on there, but instead to go through it with you as a class. And you need to understand how important this problem is. Okay, are you ready? On the AP exam, and this is both AB and BC, which, by the way, today is October 14th. That means tomorrow is October 15th, and that means you have until tomorrow to sign up for your AP exams without a penalty. Just putting that out there. You can only sign up for AB or BC. If you're planning on taking BC in the spring, put BC down. If you're planning on not signing up for BC, put AB down. Okay, moving on. This particular type of problem has shown up numerous times, year after year. Every once in a while, it doesn't show up on both the AB and BC exam as a shared problem, where they give you the graph of a derivative and they ask you, oh, when you take the BC exam, you get an AB subscore. You're getting 2 tests for the price of 1.
Nobody told me about that, and I already signed up for the AP exam, even though I'm also taking BC.
You can switch it over. It's not a problem.
I can switch it over.
You can actually switch it over in the spring. Yeah. Yeah. The one thing you can't do in the spring is sign up for the AB test because of it being a fall class. Absolutely. Yeah. Yeah. And I've gone through it a few times and I know that you can. But know that this type of problem has shown up as an entire free response problem when there are 6 free response problems, and free response problems are half of your exam. So we're talking about 1/12 of your exam has often been you answering questions based on being given a graph of f prime. Now, granted, there are some other bits that go into it. But I have seen some problems where the majority of that AP problem was what we're about to look at right now. Sometimes I've seen it be only like 1 or 2 parts, but this is important. So I'm going to tell you how to deal with these problems. And my recommendation is, if you realize you have a graph of a derivative and you're being asked questions about the original function, take a moment to chart it. And here's what I mean by chart it. You're going to, you're being asked about f. You're going to make a chart for f prime and f double prime. And by chart, I mean you're going to draw a number line along each of these. And the endpoints are 0 and 9. So I'm going to put a 0 and a 9 on the ends. you need to be able to write down where each of these functions is positive and negative. So the first thing you actually have to do is figure out where to mark down numbers where it could change from positive to negative. And that means, where is that function 0 or undefined? But you've got to orient yourself very carefully, and it is worth a good solid minute to orient yourself, even if it feels like a long time on a test. So you want to really focus in on, if I'm going to chart out where is f prime positive, negative, and I'm looking at f prime, what about that graph is where f prime is 0? Right. You're looking for the x-intercepts. So f prime is equal to 0 at 2, at 4, and at 8. But I have to look for anywhere that this function f prime is 0 or undefined. Is there a place where f prime is undefined? 6. Now, 6 is a little special, so I'm going to put a star on it so that I don't forget that it's not just some normal, average, run-of-the-mill critical number. And I also like to put zeros on top of the other ones so that I am telling myself, I know that f prime is equal to 0. It's not an undefined situation. It is 0 itself. Now, the next thing you need to do is ask yourself, what am I looking at on the graph of f prime to determine where f prime is positive or negative? Get into your own head whatever words you want to use, words you would say out loud. So, does everyone have their words of what you're looking at on the graph of f prime to figure out where f prime is positive and negative? My words are above and below. Am I above the x-axis or below the x-axis? So I will literally say those two words to myself a few times before I look at the graph. The reason being, I've done this enough times to screw up enough times to know how vital that is. So above, below, above, below, above, below. And I'm seeing above, below, above, below, above. Now I've got that charted out. Right now, I don't want to be interpreting what that means about f, because where people go wrong with these problems is if they keep going back and forth between interpreting f prime as the actual positive, negative y coordinates of the graph and changing them into slope for f. If you go back and forth, you are going to wind up going, hey, there's a relative minimum at x equals 3. Do you see what I'm saying? And I cannot tell you how easy it is until you've actually made that mistake yourself. It is easy to do. And the one time you don't want to make that mistake is on the test. All right, so here we go. Now, second derivative, we need to chart it. So you need to take a moment to orient yourself and ask the graph of f prime, as if you were f double prime. Hey, f prime, what am I to you? So you're f double prime asking f prime how it views you. And what should f prime tell f double prime is their relationship? What is their relationship? F prime looks at f double prime and it says, you're my I'm looking in chat. You're my, and I think those were some of the words popping up. You're my derivative. You're my slope. Soulmate. So, derivative, slope, derivative, slope. You're looking at the graph of f prime and you're trying to think about its slope, its derivative. Now, here we go. If I'm thinking about slope as I look at this graph, what words come to your head? What are you looking for positive versus negative? You want to find what are your words that you use. I'm wanting to know where is f prime positive and negative. So like the direction that it's heading. And those are actually the words I use for myself. I use, am I heading down or up? Heading down or up? Heading down or up? Some people may think slope, 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 negative slope, positive slope, negative. Say it a few times. I am not kidding you. Say it a few times, get it in your head, and then go look at the graph. And then see, all right, I am heading down until 3. I am heading up. And then something weird happens at 6. And then I am heading up after that. And I want to point out to you that f prime, which is this graph, is discontinuous at 6. As soon as a function is discontinuous, every derivative, however many derivative down you need to go, do not exist for that x coordinate. So if you had thought, what numbers do I want to include on my f double prime number line? You would want to think, okay, I'm looking at slope. Where is slope, 0 or undefined? Slope is 0 at x equals 3. And at x equals 6, slope is undefined because you have to be continuous before you can even be considered for differentiability. And it's not continuous. So now, here's what I recommend you do. Cover up when you're taking a test, do not look at the graph. You got this information. I'm going to lasso. And I'm going to move all of this out of the way. This is how I lost stuff on the last time. See, some of it decided I don't feel like being lassoed. You cannot take me. And then I say, ha, ha, I can come back for you. All right. So you want to take this information and literally not look at the graph and see what questions you can answer without looking at the graph. On the AP exam, there will be questions where you're going to need to go back and look at the graph. But you want to see how much you can pull out of these two. Sometimes it is a lot. Sometimes it's maybe one question out of 4. But still, one question out of 4 is a big deal. So here are the varieties of questions. A, on what intervals is f increasing or decreasing? So what I'm going to do is I'm going to write down letter A, f increasing / decreasing. On an AP exam, it's a good thing to just write down what that means you're looking for. If f is increasing, that means f prime is greater than 0. If f is decreasing, that means f prime is less than 0. Literally writing those things down can help you, 1, to look for the correct information, and 2, If the problem asked you to show your work or justify your reasoning or explain how you know, this is what they're looking for. They're looking for you saying, I understand that f is increasing when its derivative is positive. When you get to the AP test, that's going to seem like such an obvious thing that it doesn't need to be said. But you've got to remember that they are testing you on your calculus knowledge. Everything that is a calculus knowledge needs to be said. And you don't have to have proper English, as I just demonstrated. So here we go. If you're looking at the charts, then you're going, all right, f prime is positive from, oh, by the way, I'm going to add in the word open intervals, which open intervals is it increasing, so we don't have to deal with the endpoint problem. So 0 to 2, 4 to 6, and 8 to 9. Oops. Okay. And then f prime is negative from 2 to 4 and 6 to 8. And another thing you need to get into the habit of doing is always naming your function the whole way through and not pronouncing, and because people make the mistake of saying its slope is negative. And when you have more than one graph going on in your problem, saying it means you did not explain anything. Okay, so that was the first one. And again, I added the word on what open intervals. And I forgot to tell you that at the beginning. Okay, now B. What values of x does f have a local maximum or minimum? Now I want to point out to you that it said at what values of x, because you cannot know the x and y coordinate together. Do you see that you can determine where x has a minimum maximum, but you can't determine what the actual y coordinate is because you don't know the original f. So you're only finding the x coordinates for local minimum maximum. So I'm going to come back over here. I'm going to erase what I had before so that I can write new stuff. So you're looking and you're thinking. And I have to tell you that after studying the EP test for a couple of decades, I have learned what things to just start writing down immediately. Because one, it helps you to focus your thoughts where you want them to focus. And two, it actually runs as a justification at the same time. You're going to have to say it anyway. So we're going to be using the first derivative test to determine relative max-min. According to the first derivative test, a relative maximum occurs when f prime changes from what to what? Positive to negative. And by the first derivative test, it doesn't help. I mean, it's always good to say what you're using. Sometimes they want you to say the test or the theorem you're using. So it's a good habit to write it down. And now I'm going to go over and I'm going to look for f prime changing from positive to negative and see that that happens here, here. Oh, and I need to be careful about 6 because something weird was going on. To be able to say that there's a relative maximum at x equals 6, what has to be happening with f? Beyond just the positive to negative derivative. Has to be continuous. Excellent. So I want to go back and I want to point out to you some of the words that when you're first reading a problem, there are words you don't notice, but later go, wait a minute, is this happening? And this says the graph of the derivative f prime of a continuous function f. So it feels like they just kind of threw that out there like, dink! Let's see if they remember. And kind of slyly, and you don't really see it until you realize, wait, I need more information. And then you go back and you read and go, oh, they told me already, and I just didn't think about it. So x equals 2 and 6, you know you're good, and the justification is already there. For relative minimum, write down the reason why you can say a relative minimum occurred. And for relative minimum, first derivative test says f prime changes from negative to positive. And the first derivative test tells me that as long as I have a continuous function and the slope changes from negative to positive, and you can even draw it out, down, up, relative minimum. So now I go over to my f prime chart where I named it f prime so that I would look at it under the right circumstances, and I'm looking for negative to positive. And I see negative to positive, negative to positive. And again, I can't say what the y coordinates are, but it only asks me for the x coordinates. Now, the next bit. By the way, okay, we get out of this class at 10:50, right? I need to start you at 10:40 on your quiz. People were definitely using that full 10 minutes on today's quiz. So I need to make sure to get through this. Okay. Concave up or down. Where is f concave up or down? You go over to f double prime. And for me, I would write f double prime is concave up. I'm just going to do up alone, okay? You know what down is. You can see that it's where the second derivative is positive. The second derivative does not exist at 6, so I really should not be including it. And then I want to add because the second derivative is positive over those intervals. The next one was point of inflection. And point of inflection occurs as long as you have a continuous function, which we do, where the second derivative changes its sign. So I'm going to write down f double prime changes sign because that's what I need to focus on. And it changes sign at x equals 3. So that's why I have a point of inflection. I'm going to have to really quickly graph this function for you. And you can look back at the video and make more sense of it later. I'm going to erase because I really need to start you in within 2 minutes. Okay. So based on this information, the problem said that f of 0 was equal to 0. I'm not going to go show you, but I will tell you that it said that. So it gave you a starting point. Now, as I go from 0 to 2, I'm heading up with a sad look on my face. And I am going to hit a 0 slope when I hit 2. Now, I'm still continuing to be sad, but now I'm heading down while I'm at it. until I hit 3. When I hit 3, I'm going to continue down, but change my concavity to concave up. So I'm just going to say, here's 3. So I've got a point of inflection. I continue heading down, but with a smile. So now I'm trying to change that concavity look. Now the next big thing is 4. I have a 0 slope and I change from heading down to heading up, but I keep a smile that whole time. So I hit that relative minimum and start heading up. There's 4. The next big thing is 6, where something weird happens. We were told this function was continuous. So if the slopes are coming in where, if you look at the original function, from the left, you have a slope of 3. From the right, you have a slope of -2. That's going to create a sharp turn if I am continuous. So, excuse me, I am drawing that at 6, it hits a sharp turn. And then after 6, I have a negative slope with a happy face all the way. At 8, I hit a relative minimum and then head back up. And I just had to say that real quick. So I'm going to now release the quiz. I hope you enjoy your quiz. And I am going to put the link in, copy link address, and paste the post, and enjoy.